Hello and welcome back to Stumbling Through Security with your host, Sean Goodwin. Today we'll be continuing the theme with the CIS critical security controls, and we'll be focusing on the first half of the foundational CIS controls. So that'll be control 7 through 11. Show notes for today can be found at seangoodwin.blog/STS009. And within those show notes, I'll make sure I link back to each of the blog posts that's going to cover these controls in much more detail. So with that, let's jump right into it. The first control we're going to talk about is control number 7, email and web browser protections. And the full text of what the intent of the control is, quote, minimize the attack surface and the opportunities for attackers to manipulate human behavior through their interaction with web browsers and email systems. This one's really important because as the industry as a whole continues to mature and the technologies get better and better at stopping the attackers, they're moving more of these attacks to the human side of the attack surface. If your firewall and your web servers are really secure, I could spend months trying to find a vulnerability in those systems, or I could craft a phishing email and send that to a handful of employees, and I'm going to have much higher success rates with that sort of attack. So that's really something to pay attention to. And the web browsers and the email systems are where those attacks are most likely to come through, whether it's a phishing email or something like a drive-by download on a compromised site. When we're looking at the implementation groups here, there's only one control for implementation group 1 here, and there's 7 once you move up to implementation group 2. The one we want to focus on at a minimum is using a domain name system, DNS, filtering service to help block access to known malicious domains. So what we're looking for here is to try and stop at least that low-hanging fruit of drive-by downloads and phishing emails. One common issue you'll see here, especially now in the year 2020 with coronavirus having almost everyone working remotely, is your end users may be on laptops and not necessarily always on VPN. So you need to look at solutions that also have host-based control. That way, if they're not on the corporate network, the endpoint is still being protected. There's a few different ways to handle this. A lot of the enterprise-grade endpoint protection solutions will offer this or have the capability to, whether it's a module or an add-on, a lot of them have the ability to intercept those DNS queries and do their own blacklisting of known bads. There's also the Pi-hole project based on Ubuntu that runs on a Raspberry Pi that can act as that DNS sinkhole. This is really great for the home network. For any folks that are looking for a new project, it's essentially plug and play for you once you get the device imaged, but something you can look into. And there's also the OpenDNS option from Cisco, where you can outsource your DNS lookups and the filtering of those lookups to the OpenDNS servers, and they've got a bunch of categories that you can use for blocking any of those known bads, whether it's outright malicious, like the control here is looking for, or if it's just by category things, the typical adult content, gambling, violence, that sort of stuff. So with 7, pretty straightforward there. At a minimum, you want to make sure that you're working through the ability to block those known bads. On a similar note, moving on to control 8, malware defenses. So again, going to be a lot of focus on the endpoint here. The full control text is control the installation, spread, and execution of malicious code at multiple points in the enterprise while optimizing the use of automation to enable rapid updating of defense, data gathering, and corrective action. All right, so there's a lot within this control. When we're looking at the implementation groups, there are 3 different things we'll need to do for implementation group 1. The first one is making sure that your anti-malware solution is updating the scanning engine and the signature database on a regular basis. They don't necessarily determine what that basis is. Most of those tools update several times a day, if not at least daily. That's for both the scanning engine and the signature database. You also want to make sure that you're configuring devices so that they automatically conduct a scan of removable media when it's connected or inserted to the device. So if someone has a thumb drive, as soon as that's plugged in, before they can access the content, it should be scanned for any malicious documents or software. The third control here is to configure devices to not auto-run content from the removable media. So if they plug in a thumb drive, it shouldn't automatically execute. They should be prompted as the user what they want to do with that device. If they want to open it up in, say, File Explorer, it needs to be scanned before those files can be accessed. Probably the most famous instance of the USB infections is the Iranian power plant, Stuxnet, as you know, a lot of people refer to it, where they did USB drops, and certainly there's plenty of other attacks that don't get as much attention, but all three of these controls in implementation group 1 can be used to combat that sort of attack. So the first one, making sure malware stays up to date. Since we're working with generally a blacklist approach here, where you have a list of known bad files or known bad strings within files, we need to make sure that that's being updated as new attacks are identified. If you're checking for only the threats known 3 months ago, you're likely missing a lot of things. The second one, removable media, especially at trade shows and conferences and things like that. A lot of companies give out these branded USB drives, but you may just find one in the parking lot and curiosity gets the better of you. You want to take a look and see what's on there. It could be with good intentions. You just want to get that back to the owner. But if that removable media isn't being scanned by the anti-malware solution, the user is then going to be put at risk. The third one, as far as blocking Autorun, this is another one that should be almost seen as a safety check, since some of the earlier controls were really focusing on limiting software to limiting devices to only run software that we approve. But here we're also going to make sure that that removable media isn't being automatically mounted and executed. Some things that aren't called out in the implementation group 1 that I think are worthy of consideration from your point is the monitoring. So you could follow this implementation group 1 and have regularly updated malware scanning engines. You could be blocking Autorun, you could be scanning removable media. There's nothing around monitoring in that control. So that's something that you really want to consider getting eyes on. That way you can start to see trends across the network, or you can start to react to what might be a larger incident. Hopefully back in Control 5, when you're developing that configuration standard for devices, you are addressing the use of removable media, and you can start to reduce the workload for this Control 8. All right. Control 9 here is the limitation and control of network ports, protocols, and services. And the full text being manage, meaning track, control, and correct the ongoing operational use of ports, protocols, and services on networked devices in order to minimize windows of vulnerability available to attackers. So what we're doing here is really trying to shrink that attack surface. And the one implementation group 1 control we have here is to apply host-based firewalls or port filtering tools on end systems with the default deny rule that drops all traffic except those services and ports that are explicitly allowed. So that's fairly standard when we're talking about firewall rule sets, the default deny all, and then only permit what's needed. But here we're looking at host-based firewall. So this is everything in the network having that level of control. And really where this is going to benefit you the most is restricting that lateral movement between end user workstations. Even if it's something like using the built-in Windows firewall, Windows Defender, to limit that workstation to workstation communication, you're going to see a lot of benefit there. In any of our penetration tests, that's almost, probably the second step. Once we get a foothold, step one. Step two is now, what other machines can we access from this standpoint? And if you don't have that host level restriction in place, now it becomes much easier to move throughout the network because you can reach users in other departments that might have access to different types of data. There might be different credentials exposed on those machines. So really restricting that lateral movement is going to make the attacker's job significantly harder. What you're looking at here, so there are the built-in tools to most operating systems. I did reference the Windows solution. Most operating systems have a fairly good local firewall. When you start looking at the commercial solutions, the usability and administration side of things tend to get a little bit easier, but certainly not required for this. Within the show notes, I actually linked to a pretty good write-up of managing Windows firewall rules via group policy, which is nice because you essentially create the policy once and then use GPOs to push that out to folks. And then you can start to get really granular with these departments are in this OU, get this policy, others do not, and can start to really fine tune the level of access being granted to those devices. Control 10 is the data recovery capabilities. Finally, we're getting to a little bit of the backups. The full text here, the quote, "The process and tools used to properly back up critical information with a proven methodology for timely recovery." So with this and implementation group 1, we're looking at 4 different controls here. The first one, ensure that all system data is automatically backed up on a regular basis. Hopefully, folks are using centralized storage for critical documents, so that becomes much easier. If you have a dedicated file share, you can back up that device. The second one, ensure that all the organization's key systems are backed up as a complete system through processes such as imaging to enable the quick recovery of an entire system. This is something many folks may not have in place. What you're looking for here is not just backing up that end user data, but actually backing up the entire system. So if that physical server blows up, is burnt down in a fire, what have you, you're able to essentially recreate it very quickly without having to rebuild a server from scratch. This does become a little bit more difficult as now there's a much bigger scope for the backup tooling, but it's something that's really going to aid in that recovery process. This may be something you take a risk-based approach and you've got a handful of critical systems that you're going to do full system imaging, and maybe some of the less important or ancillary systems are close enough to that default template image where in a disaster scenario, you can restore those critical systems from the full image, and then over the course of the next day or so, rebuild those ancillary systems. That may be one approach to take. The third item here, ensure that backups are properly protected via physical security or encryption when they're stored, as well as when they're moved across the network. This includes remote backups and cloud services. So this is one that if you work in any sort of regulated industry, whether it's healthcare, the financial industry, this is one you should already have in place. Most of the privacy laws require that those backups are encrypted. So at least once they leave your data center or your server room, those backups, whether it's backup tapes, backup drives, should be encrypted. Backing up with encryption over the network may be something that folks struggle with. Some of these tools that are in place already, kind of legacy backup solutions, don't use encryption when transmitting those across the network. One thing that can be useful there is logical protection. So using VLANing to have a backup network separate from the production network, but really making sure that those backups are protected. Really, it hits on all three parts of the CIA triad. So the data being included in those backups is likely confidential, and folks that have access to some of it probably don't need access to all of it. And if that's being transmitted clear text, you then start to risk exposure there. The integrity, you want to make sure your backups are trustworthy and that you can actually restore, not only that it'll be functional, but that the data is accurate. And then the availability. If that data is not encrypted in transit, folks may be able to identify, okay, this is backup data, and then you start to have some concerns there. All right. And then the last sub-control we have here is ensure that all backups have at least one offline, meaning not accessible via a network connection, backup destination. This could be something like a cloud-based backup or hosted backup solution, or it could be as simple as having the legacy backup tapes or backup drives that are then disconnected. The concerns here are a fewfold. The first one that comes to mind is, wormable ransomware, right? So we saw WannaCry is a really big example of malware that started encrypting your files, but then also looked for any other network connected file share and essentially spread itself or spidered throughout the network. So having some of those backups available offline will certainly aid in the recovery. I think the best example of that coming true is with the Maersk ransomware attack. So Maersk, the shipping company, essentially had their entire global operations shut down with ransomware. And not that this was necessarily put in place by design, but they had one location that went offline due to a power outage. I think it was somewhere in Africa, the office. They had a domain controller that luckily, I believe, was a global catalog, so it had everything they needed. Didn't get encrypted, and they were actually able to rebuild the entire global network from that, what we'll call a backup in this situation. So it does have real world impact for sure. The other concern is that if everything is networked, right, and you don't have one offline, you then run into the concern of how quickly those backups are taking place. So essentially, if it's a real-time backup, how many iterations of those backups are you keeping before any of the good data is overwritten? So if you have an issue and you have backups on this critical file share being run every 5 minutes, there's an issue that corrupted a key file and you don't find out for 3 days, likely all of those snapshots are going to include the corrupted version and you may not have the clean version to roll back to. Certainly a lot of the tools do the incremental backups, so you'd over time be able to roll back each kind of step along the way until you get to a known good file. But having things offline does allow for that, essentially plant the flag in the dirt. We know this is the backup. Certainly if that backup is taken with a bad file, then you are stuck with it. So it's not a perfect solution, but certainly can provide some protection there. One thing that I found interesting being left out of this control set is to test the data on backup media. So implementation group 1 really focuses on getting that backup process in place, but there's no testing of the data. So you don't actually know if this backup is going to be usable, right? That's certainly something you want to keep in mind. And if you're following along the implementation group guidance, I would definitely highlight testing the backups, at least on a periodic basis, to make sure not only is your backup process adequate, so you're capturing everything you need, but that it's actually functional, and in the event of an issue, you'll be able to restore. All right, the last control we'll talk about today is Control 11, secure configuration for network devices such as firewalls, routers, and switches. And the full text being, quote, establish, implement, and actively manage, meaning track, report on, and correct, the security configuration of network infrastructure devices using a rigorous configuration management and change control process in order to prevent attackers from exploiting vulnerable services and settings. This should sound pretty familiar, especially when we're talking, kind of looking back at controls 2 and 3. But really what we're looking at with the one implementation group 1 control here is installing the latest stable version of any security related update for all network devices. So the overall control heading is pretty familiar to those earlier controls where we're designing really detailed configuration guides with here's the software that can run, here's the configuration that must be in place, and we're going to periodically check this. That's what the control gets to with some of the later implementation group controls. But for starting out with implementation group 1, all we want to do is make sure that the latest patches are installed on those network devices. A lot of these devices tend to be run a lot longer than servers and workstations because they're on your internal network for the most part. The likelihood of them being attacked is pretty low. And when things work, it tends to be left alone. But this is certainly something you want to stay on top of. The biggest headline around this sort of attack is probably the Pulse VPN attacks from a little over a year ago, where you have these VPN appliances that are exposed to the public internet, had an issue where essentially the clear text credentials were being exposed to the internet. There was a patch released a few months before the full disclosure, but even 6-8 months after the disclosure, we were seeing a ton of folks with these devices publicly exposed without having that patch installed. So this is something, definitely prioritize those publicly accessible devices, but really if you're able to standardize the patching process for these network devices across your environment, you're really going to win out. A lot of the vendors will have their own tools for managing configurations and patch levels with these devices. From a third-party perspective, Nipper is a great tool. They have a paid version and a free version that can really analyze those configuration files. It does a lot more than checking for patches, but it will also highlight if there's security patches missing. Any of the other vulnerability scanning tools we talked about earlier will also highlight these sorts of things. All right, so that's what we have for today. That's the first half of the foundational controls 7 through 11. Certainly stick with us through the series. We're just over halfway through the controls at this point. We'll get back to a blog post per control, and then once we wrap up with the foundational controls, you can look for another podcast episode. Show notes for today can be found at seangoodwin.blog/STS009. Talk to you again soon.